Welcome. In this lesson about Introduction to Prompt Engineering, the intended learning outcomes are, by the end of the lesson, you should 1. Be able to describe what prompt engineering is, and 2. Identify some important prompt features and their impact when prompting LLMs. Prompt engineering is the manual process of designing and refining plain text prompts, or hard prompts, provided as input to an AI model for expected outputs. To achieve the best results, first, it's best to use the most capable LLM and set the hyperparameters accordingly, e.g. the temperature, which determines creativity. Prompt engineering is different from prompt tuning, which is the machine learning of soft parameters as continuous features, called soft prompts, or context engineering, which is the broader system design involving strategies for optimal LLM information input. Prompt engineering today is more predictable and less of a painful experience than what it was a few years ago, because LLMs are now more capable with better natural language understanding, resulting in better outputs for even simple prompts. Prompt engineering is more relevant for generative models, while reasoning models give better outputs from high-level guidance instead of detailed engineering. For both, prompting for step-by-step or chain-of-thought outcome is usually useful. Natural language as AI prompts instead of complex codes makes AI accessible across industries. There are two main types of prompts: system prompts and user prompts. System prompts target persistent behavior across model use and are typically hidden from user interface, while user prompts are regular prompts at the user interface for specific goal or task and are influenced by the system prompt. Both share many common features. Be ready to refine and iterate the prompt. Some important prompt features are: 1. Be clear. 2. Be specific. 3. Provide sufficient detail. 4. Provide context. 5. Assign a persona. 6. Provide few short examples where applicable. And 7. Describe the desired format. The impact from these features are precise, bespoke, relevant, effective, and more accurate outputs. Positive instructions and examples that tell the LLM what to do work better than negative examples of what not to do, though it is fine to tell the model what not to do. Let's consider an example in the legal domain where our goal is to summarize a very lengthy document without losing the most important information. In the end, it is important to evaluate if the LLM was successful based on metrics we may have defined. So our initial prompt may be: summarize this sublease agreement. This prompt is very simple and may not give us the best output. We may then re-engineer the prompt with some of the features we talked about so that it becomes: summarize this sublease agreement like you are a legal expert in Sweden, providing important information about the parties, responsibilities, property, details, rent, and any special provisions. Now, it is most likely the LLM will give us a summary that captures important points with sufficient details based on our evaluation metrics. In the example, a legal expert is the persona, Sweden is the context, and we were specific with the important pieces of information. Similar examples are possible in other industries, or code writing, usually called vibe coding. Now, as a takeaway task, I would like you to 1. Differentiate prompt engineering from prompt tuning, and 2. Identify 7 features for engineering better prompts for LLMs, and maybe think of an additional one. Thank you.